Hi guys, welcome back to my channel Pretty Girl TV, and today we will be discussing extensively on waves. A wave is a disturbance that travels through a medium, transferring energy from one point to another. Waves are a fundamental concept in physics and are used to describe a wide range of phenomena from water wave and sound wave to light wave and seismic wave. Types of waves. There are several types of waves, including 1. Mechanical waves. Mechanical waves are waves that require a physical medium to propagate. Examples include water wave. Water wave that travels through the surface of a body of water, such as ocean waves or ripples on a pond. Water waves are created by wind friction on the surface of the water, which transfer energy from the wind to the water. The energy is then propagated through the water in form of wave. 2. Sound wave. Waves that travels through a medium such as air, water, or solid. Sound waves are created by vibrations or disturbance in the medium, which transfer energy through the medium in form of pressure wave. The pressure wave then reach our ears, allowing us to hear the sound. 3. Seismic waves. Waves that travel through the earth's crust, often caused by earthquakes or volcanic eruption. Seismic waves can be classified into two main types: body waves and surface wave. Body waves travels through the Earth's interior, while surface wave travels along the surface of the Earth. 2. Under the types of wave. Electromagnetic waves. Electromagnetic waves are waves that can propagate through a vacuum and do not require a physical medium. Examples of electromagnetic wave are: 1. Light wave. These are waves that are visible to the human eye, including ultraviolet and infrared radiation. Light waves are created by the vibration of charged particles such as electrons and can travel through a vacuum. Light waves have a wide range of applications, including vision, communication, and energy production. 2. Radio wave. Radio wave is another wave of electromagnetic wave. These are waves that are used for communication and broadcasting, such as radio and television signals. Radio waves have a longer wavelength than light waves and can travel long distance through the air. X-rays. These are waves that are used in medical imaging to visualize internal structures. X-rays are high energy electromagnetic waves that can penetrate solid objects, making them useful for medical imaging. Properties of waves. Waves have several properties that are essential to understand their behavior and applications. Some of the key properties of waves include: 1. Amplitude. The amplitude of a wave is the maximum displacement of the wave from its equilibrium position. Amplitude is a measure of the wave's intensity or energy. The larger the amplitude, the more energy the waves carries. 2. Wavelength. The wavelength of a wave is the distance between two consecutive points on the wave that are in phase with each other. Wavelength is typically measured in meters. The wavelength of a wave determines its frequency and speed. Wavelength is the distance between two crests or torques. 3. Frequency. The frequency of a wave is the number of oscillations or cycles per second. Frequency is typically measured in hertz. The frequency of a wave determines its pitch or color depending on the type of wave. 4. Speed. The speed of a wave is the rate at which the wave propagates through a medium. Speed is typically measured in meters per second. The speed of a wave depends on the properties of the medium, such as its density and elasticity. 5. Period. The period of a wave is the time it takes for one complete oscillation or cycle. Wave behavior. Waves exhibit various behaviors, including 1. Reflection. Reflection occurs when a wave bounces off a surface or boundary. Reflection can be specular, which is mirror-like, or diffuse, which is scattered. Reflection is an important phenomenon that allows us to see objects and images. 2. Refraction. Refraction occurs when a wave passes from one medium to another and changes direction. Refraction is caused by a change in the speed of the wave as it passes from one medium to another. Refraction is responsible for many optical phenomena, such as the bending of light as it passes through a prism. 3. Diffraction. Diffraction occurs when a wave passes through a narrow opening or around a corner. Diffraction is the bending of waves around obstacles or the spreading of waves through small openings. Diffraction is an important phenomenon that allows us to understand how waves behave in complex environments. 4. Interference. Interference occurs when two or more waves overlap and combine to form a new wave. Interference can be constructive, which is resulting in a larger amplitude, or destructive, which is resulting in a smaller amplitude. Interference is an important phenomenon that has many applications in physics and engineering. Wave applications. Waves have numerous applications in various fields, including 1. Medical imaging. Waves are used in medical imaging techniques such as ultrasound. It uses high-frequency sound waves to create images of internal organs and tissues. Ultrasound is commonly used to diagnose and monitor conditions such as gallstones, kidney stones, and liver diseases. 2. Magnetic resonance imaging. It uses magnetic waves and radio waves to create detailed images of internal structures. The magnetic resonance images is commonly used to diagnose and monitor conditions such as tumors, injuries, and neurological disorders. Computed tomography scans. It uses X-rays to create detailed images of internal structures. The computed tomography scans are commonly used to diagnose and monitor conditions such as tumors, injuries, and vascular diseases. 2. Communication. Waves are used in communication systems such as radio waves. It's used for broadcasting and communication, such as radio and television signals. Radio waves have a long wavelength and can travel long distances through the air. Microwaves. It's used for wireless communication such as mobile phone and satellite communication. Microwave have a shorter wavelength than radio wave and are used for high frequency communication. 3. Optical fibers. It is used for high speed data transmission such as internet and telecommunications. Optical fibers use light waves to transmit data through thin glass or plastic fibers. 3. Navigation. Waves are used in navigation systems such as the Global Positioning System, which is GPS, the sonar, which is sound navigation and ranging, and also in radio detection and ranging. In conclusion, waves are a fundamental concept in physics that describe a wide range of phenomena. Understanding wave properties, types, and applications is essential for developing new technologies and improving our daily life. Okay guys, I'm going to stop here for today. Please, if you find this video interesting and information, please like, subscribe, and share this video to family and friends. Bye for now. See you in my next video.